Am I audible?
Yes, sir, you're audible.
Okay, so I hope that I'm audible to everyone and my screen is also visible at your screen.
Yes, sir. Yes.
Thank you, thank you. So let's start with today's webinar. Today's session is a very important session for everyone whosoever is interested in the field of Internet of Things or IoT. And today's webinar topic is sensors to server. And here we are going to discuss the TCP sockets. We will see the hands-on demonstration of TCP sockets with ESP32 microcontroller and the Raspberry Pi. So let's start with this topic. First of all, let me introduce myself. I'm Himanshu Tripathi, working as scientific officer at AKGEC Skills Foundation. I'm a great open source enthusiast and a very active part of the innovation ecosystem. And on the screen, you can see a very brief introduction about myself. That I'm since a long time, I'm into the designing of embedded systems and IoT applications. Here, my email ID is also mentioned, and if you think that I can help you in somewhere in your projects or in your learning journey, please feel free to connect with me through this email ID. Okay, the very first thing that comes into our mind that why this topic matters to all of us. I have selected the topic for today's session is the sensors to server. Like we are all interested that how we can sense some data, rather than not how we can sense if we are sensing some data using any sensor, then how to transfer or how to communicate that data to the server. Server is always thought as the main brain or the main component of your entire IoT application. So we are moreover interested that what really happens when sensor reads any data and our target is to sending that data. The Yeah, so sorry. We are more interested in what really happens after a sensor is reading some data, and we are interested, or our aim is to send that data to a server. And let me tell you here at this point of time that it is the most crucial part of any IoT application or IoT ecosystem. Most of the time, the IoT system or IoT application fails at the communication level only because sensing the data is maybe a foolproof mechanism. And the later part of the IoT that involves with data handling and the visualization creation with that data is also very much robust and very much trustworthy. But the important chain that is linking these two ends of this IoT ecosystem is the communication, and we are here trying to understand that how we can communicate data which is coming from any sensor to the server. So let me ask you one question that is very simple: that how many of you have used HTTP protocol or MQTT protocol without knowing that what protocol runs below it? Uh, I'm telling you that there is a protocol which is running below the HTTP, or it may be the MQTT, or it may be the COAP. So many IoT communication protocols are there. So if you know already about it, that okay, if I'm using HTTP, then someone else or some other protocol is also responsible for sending that data from one computer to another computer. So let me tell you the important protocol that is running always underneath of HTTP or MQTT or any similar IoT communication protocol is the TCP protocol. Most of the time, we used to call that protocol as TCP/IP. So we will see very soon that what is this TCP/IP and how this TCP protocol is working and how we can use that TCP protocol. But before I start the things, let me decode each and everything step by step so that you can easily understand that what is TCP protocol and how that TCP protocol is actually can be implemented with our IoT hardware. It may be the microcontroller unit or it may be the Raspberry Pi. I am presenting you here a typical IoT architecture. Let me tell you one more thing, that this is not the standard IoT architecture. This is a very common, very basic architecture for any IoT application. And as we all know that IoT architectures are basically are designed in the form of layers. Different layers are representing different technology or different functions. This architecture is starting with the sensing layer. At the bottommost of this architecture, we have put the sensors. Sensors are the devices which are responsible to sense any physical parameter, and after the sensing of those physical parameters, they tend to generate some electrical output in the form of voltages or currents or similar to that. Then, after sensing those parameters, we need to decode or understand those parameters. For this purpose, we require a microcontroller. It may be a very basic microcontroller, 8-bit microcontroller, let's say, like we are using Arduino Uno R3 in most of the cases. But here, if we are interested in sending the data to the network, that means one crucial thing is also required along with the microcontroller, and that crucial thing is the network connectivity feature. So for this purpose, microcontroller selection is very important for your IoT architecture. Then through the microcontroller, the data travels through the network, and after the network, it finally reaches up to the server. And on that server, some applications may be running, and that application is basically giving the insights to the user in the form of visual indications or in the form of text or any other format which is more suitable for that application or for that particular users. So this is the very basic architecture of IoT system, but we are not going to decode this entire architecture in today's session. We are interested only one thing, that what is happening when we are trying to sending data from sensor to server. So we are only focusing on these two things, sensor to server. Like we are not discussing the different type of sensors, but yes, we will tell you that if you are getting value of any sensor, then how you can use TCP protocol to send the data to the server. So this is the today's agenda, and let me start with the technical part of that thing. The very first question that comes in our mind, that what is a server in IoT? So let me tell you here one thing, that servers are not the cloud. Most of the time, I have seen that people are confusing servers with the cloud. Yes, server can be hosted on any cloud service, but definitely, uh, please mark this sentence in your mind, that server is not the cloud. Cloud is very, very big thing. That is a bigger, that is having a bigger picture than the server, because cloud is offering a lot of variety of services. It may be the data management or data storage, it may be applications, it may be virtual machines, or so many other things are there with the cloud. So, what can server be if server is not the cloud, which is a certain thing now? So, server can be any computer. It may server is definitely a program, but that program that we are calling that server is maybe running on a Raspberry Pi. That is our today's scenario, that we are going to deploy the server on Raspberry Pi. Raspberry Pi is pocket size computer, you can say. It is a full-fledged motherboard of any computer, and it is very capable and very handy, very popular device into the IoT paradigm. The next thing, any industrial PC may be a server, or you can make a server on your own laptop or on your mini PC or desktop PCs as well. And other thing is that server may be a cloud virtual machine. Since I told you that cloud may host the server. So this is the example of that house cloud is hosting the server. Server may be a virtual machine on any of the public cloud, or it may be your private cloud as well. Then the question comes that what server does. Server basically listens for the clients. They accept connections only in the case of TCP. I should say that servers are accepting connections from the client side, and they processes the data. So these are the main features of the server. Any server, whether you have deployed that server into the industry, you are creating a server for your home automation purpose or any other purpose. main task of the servers are basically listed here as like listening to the clients, accepting connection. Yes, it is in the case of TCP only, and the processing of data. So many production systems starts with edge servers, not the cloud, because cloud is pay as you go platform. And to minimize the cost, or I should say to optimize the cost or for the total IoT application, we usually deploy the edge servers in our IoT applications. If we are talking about edge servers, then Raspberry Pi or the industrial PCs are good way to go because they are cheap in cost and they are having significant performance for most of the IoT applications in industry. The next thing is the white TCP for IoT. Now we know that what are the servers, and we are trying to reach these devices as I have shown you in the previous slide. We are asking that why TCP is required for IoT. So the first thing is TCP is not all alone protocol. This is not the single protocol that is available at the network layer. TCP, along with the TCP, there is one more very popular or equally important protocol that is also known as the UDP protocol, user datagram protocol, I should say. The basic difference between the TCP and UDP, TCP is a connection oriented protocol. Like if we are using TCP, then the first thing that we need to ensure that client and server both are connected with each other. And UDP is connection less protocol. There is no need to establish any connection between the client and server before we are initiating the data transfer from the sensors or from the client to the server. So if we are quickly comparing between TCP and UDP, because this is not under the scope of today's session, but yes, it is important to know that what is the core difference between TCP and UDP. TCP is reliable protocol, no doubt. It is ordered protocol, like whatever the packets we are sending, they will be received at the server end in a particular order that has been decided by the client while the client was sending those packets. And here we are having the provision of error checking with the TCP. So TCP is more fail-safe protocol. You can say that it can basically ensure that the right data in the right order has been transmitted or received by the other end. While on the other hand, UDP is a faster protocol than TCP. Yes, it is faster because there is no need of any connection. Only the clients are basically sending the data into the form of packets, which are basically known as the datagrams, and these packets will be or will not be received by the server. That's why the second part of UDP says that it is a risky protocol. But both the protocols are important and both are having their own plus and minus, pros and cons. Like if we are dealing with systems which are dealing with medical equipments, or you can say the financial things, or very critical data is available, then definitely we need to choose the TCP protocol as a go-to protocol for our application. But if we are handling or dealing with the application where data is not so important, yes, it should reliably reach up to the final destination. But yes, if something is missing, that is not going to harm the entire process. Just for an example, we can say the video conferencing. Like if we are doing video conferencing, there is no need to establish a connection between client and servers. And if some part of the video conferencing, like I am basically delivering you the session using this video conferencing tool, that video conferencing is at this present time is using the UDP protocol, by which you are basically able to listen my voice, and you are basically able to see my screen. So TCP is a host-to-host protocol. We will see and decode this thing a little bit more deeper. And TCP is preferred for sensor data logging, industrial monitoring, financial or medical data, as I have already told you. The next part is again we are going to compare more in more detail that what is the TCP and UDP. So in the diagram, it is evident that okay, TCP and UDP, what are the things they are having, and we'll decode it that what is the SYN or SYN ACK packets. Uh, the important thing here in this slide is TCP is protocol, and we used to call it unicasting feature. while UDP is not one to one, it is one to many protocol. So we can say one to all or one to several multicasting or broadcasting feature is very much evident in the UDP. So on the basis of these features, like we want to establish a unicast network, or we want to establish a broadcast network or multicast network, we can decide that which protocol we need to use. Definitely, in today's session, we are going to going deep into the TCP protocol. So, after getting the information about the TCP protocol, let me tell you that what is a socket. Because whenever we are going to implement TCP protocol, this socket is going to play a very important role in our communication. Socket is basically known as an point of any communication network, like from where the data is entering into the network. That endpoint of that communication network is socket, and at the point where data is entering into some other device, it may be the server, then that endpoint is also known as a socket. So if the socket is at the client side, we will say that this is a client socket. If the socket is at the server side, then we can say that it is a server socket. Then the question becomes that what is a socket actually? Socket is nothing but the combination of these two critical parameters. The first parameter is the IP address, and the another parameter is the port. So IP address, we all know that any device which can connect to any network, then that device should have a unique identification number with that device, and that unique identification number is basically known as the uh, IP address of that device. Then the port is the port of your system. Typically, in a system, 64K, like 65,000 something ports are available. Some ports are already engaged by your operating system. So it is always advised to not use those ports in your general purpose programming. And otherwise, you can select any port of your system for a particular protocol implementation. So these are the two things, IP address and the port. When we are combining these two things together, this becomes the socket. You can simply understand this socket with the help of one analogy. That analogy is like we are living in a building. The building address is going to be the IP address, and in that building, if the particular flat or flat or the floor you are living, that is basically the port number in our system. So socket is generally depicted as the pipeline between the client and server, and by using this pipeline, first if we are implementing the TCP, then this networking or the connection is becoming critical, and through this pipeline, we can send data from client to server, or we can receive data from server to client. So this is the more clear picture about the socket. Like here we are having one host, one web server here. Let's say that the IP address of that host is 146.86.5.20. These are the IP version 4 IP addresses, and the IP address of web server is also basically visible on your screen. So when any data from any application which is running on this particular host is leaving this computer or this host, that data is having two critical identification parameters, like what is the IP address of that machine where that data is residing, and how what is the port number. And then the data leaves that host, and through the internet it travels and reach to the socket of the web server or another machine. So this is all about the sockets. I hope that now at this point of time you must be able to understand that what are the sockets and what are the IP addresses. Now we understood one thing, that if we are combining these two things together, then we are eventually creating the sockets. Now let's come to the main thing, that what is the TCP/IP and how this TCP/IP works. So to understand the TCP/IP working, TCP/IP means there are the combination of two protocols. TCP is one protocol and IP is Internet Protocol, that is another one. Most of the times these two protocols works hand in hand or works all together. The data which is leaving from any system is basically being handled by the TCP. TCP is responsible for creating or slicing that data into the small forms. These are known as the packets. Then IP protocol is basically responsible that how that data is traveling through the internet. And again, at the on the other hand, the same situation is. So if we are more interested to understand TCP IP, that how data is traveling from one device to another device, the first diagram is more useful for us. So here in the first diagram, I've shown you that let's assume that we have a web page on a web server, and we want to transfer that web page on another computer, right? So the TCP role is basically to divide the data, whatever available in the format of this web page, into the smaller packets so that these packets can be transmitted through the network. So let's assume that that data has been basically fragmented into three packets: packet number one, two, and three. Now these are the routers. These routers connections are basically depicting the internet, whatever it may be present here. So at this router, all these three packets are coming, and now the router is deciding that which packet will follow which path. So let's say that packet one is basically following from this router to again this router R, and packet 2 and 3 are basically traveling through this another router. So here finally all those packets are arriving at this socket, which is the socket of your computer. And the important and the good part of TCP is that it doesn't matter whether packet 1 arrives early or packet 2, 3 are arriving early. At the socket, the data will be received in the ordered way, the same order, whatever has been decided by the sender or the transmitter. So here, let's say that we have decided the order that first the packet 1 should reach, then 2, then 3. Then at this socket, all that data will be received in the same order, whatever has been decided by the web server. This is the entire mechanism how we can access data using the TCP IP protocols. So some of you may be interested in that what is the importance or what is the role of TCP IP protocol if we are concerned about the different OSI layers in the network. So for that understanding, I have selected this diagram. Here, the sender is basically generating data or sending data through an application. So the application layer is involved first, then the transport layer come into the picture. Then finally, the data is going into the internet layer, network access layer, and through the internet, the data arrives at the network access layer of the receiver end. Then the same sequence in the reverse order, like after the network access layer, the internet layer is responsible for this communication, then transport layer, and then application layer, so that the receiver can get the data in the same ordered format and with the full integrity. This is the beauty, or this is the nature of TCP protocol. So I hope that these two analogies are very much simple to understand, that now you will be able to understand that how TCP is working along with the IP. Most of the time we are using TCP IP in a same sentence or in a same word. So the next important thing, this is only a technical thing that I want you to know about the TCP, is the three-way handshake. All the reliability or all the functionality of this TCP protocol is basically depending upon the three-way handshake mechanism. Uh, because of this three-way handshake mechanism only, we can say that TCP provides us a reliable communication medium. In this three-way handshake process, three TCP segments are exchanged between the sender and the receiver to establish a reliable connection. We will see in the further slides that how what are these three steps or three these segments, and these are basically known as SYN, that is acknowledgement, and acknowledgement itself. So this is the step number one. So if we talk about the SYN, that stands for synchronized sequence number. So the first, the client basically send this number to the server, then server acknowledges this number, and then again the client receive this number and then again acknowledge to the server so that the connection has been established. The second step is data transfer phase, and in the data transfer phase, again, once the connection has been established, then only we can initiate or start the data transfer. And for that data transfer, we are using these two things: this number, SYN number, and the acknowledgement. So data request through HTTP or through MQTT, it may be basically transferred from the client to server, and this is the way how the data has been transferred between the client and server. The third and last but not the least stage of this three-way handshake is client acknowledges the response of the server by acknowledgement message, and status on both sides change to the established, and both get ready to start the actual data transfer. So you need to understand here at this particular point, these three stages are not significant to tell you that how continuously data is being transferred between the client and server. These are the initial stages of TCP. When we say that, okay, now TCP connection is established. So for the establishment of that TCP connection, these three stages are important. And if any one of this stage fails, then TCP connection is not established, and we cannot communicate between the client and server, or between one machine to another machine using the TCP sockets or TCP protocol. Okay, now let's come to the main point here, that how we can implement this TCP communication. So for today's session, I have decided to implement these TCP protocols with the language Python, which is very popular among all of you, I believe. So in Python language, we are having a specific module to handle that TCP communication or UDP communication, like socket communication, I should say. The Python socket module provides an interface to the Berkeley sockets API. If you will go into the history of sockets, then you will know that what is the Berkeley sockets. These are the foundations of all the modern day sockets. So here in this diagram, you can understand this thing more clearly. Like here we are having server, and here we are having the client. These are the stages or the steps that we need to implement while we are using the Python programming to establish the socket connections, or to communicate data using the TCP IP protocol. The first thing in the server side is we need to create the socket. This is very important. And in the programming, I will show you that in the program, we are following the steps in the same sequence. And with the Python, what are the modules, or what are the functions or APIs that are needed, which we can use to implement these steps. The first step is creating socket. So we need to create a socket first, and then we need to bind that socket with the server IP and the server port. Okay, let's understand that port is going to be fixed on the server program, because whatever the data is coming to your terminal, your PC, that data is required to, or that data is supposed to go or reach up to the specific program which is running in the name of server on your machine. So for that purpose, the port number is fixed. So we need to bind the IP address in the port of the machine with the socket. Then that server side socket is start listening for the clients. Here we can basically create the pipeline or the queue for number of clients that we can handle at one time. And at the same time, here at the client machine, the socket has been created, and then client will raise a request to connect with the server. When server is ready to accept the new connection request, then this connect request will be entertained by the server. And after that request has been entertained by the server, then the data transfer mechanism or loop will start. So here you can see this is a closed loop, like client is sending data, server is receiving data, then server may be sending the acknowledgement most of the time, and that acknowledgement is being received by client, and again client can send some more data, then server will receive, and the same process is going to happen for a time period whatever is required for your application. And finally, at any point of time, if you are closing the client, because it is basically prescribed that after connection quickly transfer your data with the server and close the connection so that other clients may get connected with the same server. Remember, it is a one-to-one mapping scheme while we are going to implement the TCP sockets. So when your client closes this connection, then server will receive this connection closing request, and then server will close the connection also. And it depends, here in this diagram we are closing the server, but it depends, and server will again come at this point to accepting the new connection request from the client. So these are the few APIs like socket module we are going to use for creating socket. Dot bind module is for binding the socket address with the machine. Dot listen module, dot accept module, and dot connect module. These are the few modules, and along with them, we for sending and receiving data, we will use dot recv, that is receive module, and the API, or dot send API also. So sorry. Okay, what is happening in the real system? What we are going to demonstrate you today? I'm having one ESP32 microcontroller, and I'm going to configure this ESP32 microcontroller as a TCP client, I must say. And I'm also having one Raspberry Pi 4 Model B, and I'm going to configure, or I'm going to run a TCP server on this single board computer, that is the Raspberry Pi. So these are the steps that those will happen while we are establishing the connections or communication. First, ESP32 boots up, then it will connect to the Wi-Fi, because for that communication between the ESP32 and Raspberry Pi, we need a network. And for as a network, we are going to use the Wi-Fi network with our application. So that ESP32, which is coming already inbuilt with the Bluetooth modules, it will connect to the Wi-Fi. Then we will open the TCP socket on this ESP32 module, and then we will connect with the server and send the sensor data to the server. While if we are concerned about the server side, then already Raspberry Pi, definitely this device is also needed to be connected with the Wi-Fi network, or in our application on the same Wi-Fi network, I must say. Yes, we can basically transfer data on the other network, but more things are needed to be done if we want to achieve that thing. But at this point of time, in this particular demo, we are working on the same local network. Then after listening the client, it will accept the client connection, which will be coming from the ESP32, and it will receive the data, whatever the data is ESP32 is sending. And finally, this device is processing that data. In the name of processing, what we will do today's session, that we will pass that data and store that data somewhere. Okay, so this is the total demonstration mechanism, and let me quickly tell you that how these things are happening. So I am having a ESP32, sorry, right. So this is the TCP client for ESP32, and let me tell you that I'm using Thony IDE, which is a IDE which is most suitable for the MicroPython programs for the ESP32 devices. So this program, or this script, is basically written in MicroPython programming language, and as an IDE, or integrated development environment, I'm using Thony IDE here at my system. So in this program, let me tell you quickly what is happening. The first thing, we are importing some important libraries, then Wi-Fi credentials has been given. Here LED pin, I have defined it too, because if you can see my camera, this is the ESP32. When we will try to connect this ESP32 with Wi-Fi, I have made one provision that LED, which is available on board of this device, should blink continuously until and unless the connection has been fixed. Then this is the object to handle the LED, which is available on the ESP32. Then this is the server IP and the server port. This IP is the IP of your Raspberry Pi, because we are running server on Raspberry Pi, and this is the port. Remember, I told you that please try to avoid ports from 0 to 1000 or 0 to 2000 somewhere, because maximum time you may have a chance that the port number may be occupied by some program which is running on your machine or your computer. Since 65,000 something ports are available on any machine, so I'm going at to the far and further end, and I have decided this number 54321, and I believe that no application will be using that odd number as a port for their purpose. Then this is a device ID. This device ID must be unique so that on a network or on a server, I can recognize that this data is being sent by which device. So I have basically given a device ID, which is ESP32 underscore sensor underscore 002, and you may basically use any device ID as per your requirement. So this is the function that is going to be run. Let me tell you the flow of the program. This is the main function, and in the main function, the first thing we are going to run is the connect to Wi-Fi. So this connect to Wi-Fi function is being written here, and in this function, we are quickly creating the station interface. For creating interface for the station device, because here we are going to connect our ESP32 with some existing Wi-Fi. You all know that ESP32 can work in station and access point mode. So here we are configuring ESP32 in the station mode. And after that, we are quickly disabling that station interface. Then again, after 1 second of interval, we are enabling. This is if previously that station was on, because we used to do a lot of development activities on ESP32. But yes, if you are basically working with a fresh device, these lines may be ignored. There's no harm in ignoring these two lines. But if you are continuously doing development with your ESP32, I will suggest you to write these two lines, right? Then after previous, for removing the previous connections, I'm using wlen.disconnect. Then we are printing some debugging commands so that we can know that how our program is working. And here we are going to record the time as well. For that time recording provision, I'm using the inbuilt timer of ESP32, that is available on time.text underscore ms method. So finally, we are connecting the ESP32 with, we are also providing the SSID and password of our Wi-Fi network from which we are going to connect it. I'm definitely going to connect this ESP device with the Wi-Fi network of my office. Then I am waiting for some time, like I'm giving a timeout of 10 seconds, you can say, and in this time, if the connection has been established, then we will proceed into the code. And if by this time connection is not being established, then our script is going to be terminated, because if we are not connecting with the Wi-Fi, there is no point to make any communication between the client and the server, or from the sensors to the server. So after running this function that I have explained you in brief, we our ESP32 device is going to be connected with the existing Wi-Fi network. Okay, instead of sensor, we are going to use some simulated sensor values, and I'm assuming that I'm using a DHT sensor, that is the digital humidity and temperature sensor. And from the sensor, I'll be getting two values, one for temperature and another for humidity. So I am randomly generating these values as a simulated value from those sensors. And the timestamp, which is very crucial in IoT applications, like we are all always interested that at which point of time the data has been measured, and at which point of time the data has been reached to the server for the analytics purpose. So here I am creating a timestamp. Then it is basically in the format of seconds since the epoch time of this device. And finally, I'm framing that data into the form of string. So here, for that purpose, I'm using a formatted string function called Python. That is, we are basically putting all these four parameters into that string. The device ID, I have defined that what is the device ID. Then timestamp we have created from there. Then the temperature and humidity, which are the simulated value of the sensors. So in the main script, what we are going to do, because it is a client, the first function that is required is to create a socket. So for socket creation, we have written socket.socket. That is from the socket library. We are calling the socket method, and here we need to provide two parameters here. These two parameters that I've highlighted here. So the first parameter is basically telling you the family of socket. That family, if you're adding AF underscore INET, these are the standard notations available with Python. we are using inet only, that means we are using ip version 4 ip addressing mechanism. And if you are using ip version 6, then you can replace this with af underscore inet 6. And the second thing is the type of socket. So I've told you that we are interested in two type of socket, TCP and UDP. And here we have written this script for the TCP socket communication. And for this purpose, I'm writing this shock underscore stream. This is the keyword to initiate or initialize the TCP sockets. If you are using UDP, then this word must be different. That should be shock underscore DGRAN. That is the datagram. Okay, and then I'm also setting up the socket timeout because if this timeout expires, then and nothing is happening, then we can close the socket cleanly or successfully. Then the next command, which is important, I'm leaving all those print commands because they are very easy to understand for you. Then the client socket dot connect. Here we are going to connect this client with our server. So for that connection, we need to put the server credentials with this function, and these server credentials include the server socket. And socket, as I've already discussed with you, that socket is nothing but the combination of IP address and the port. So here we are basically connecting the server IP address and the server port that we have decided. After that connection has been established, then our system is ready to transmit or receive the data or the send the data. So the first thing, we are getting the simulated sensor data along with the device ID, and we are sending that data, all the data, to the server. For sending all the data, I'm using send all function API for the TCP sockets, and here you can see dot encode. Remember, the data is available into the format of string. Here in this function, I have created the data into the format of string, but the data cannot travel into the format of string into any network. So to make that data enable to travel any network, we need to encode that data into the byte format. So for that byte format encoding, I am using sensor data dot encode, and the formatting scheme that we are using, that is UTF-8. And these are some error handling processes. If anything is going wrong, then we will get the appropriate error so that we can easily debug our script. And finally, we are closing the socket. So this is the script in MicroPython, which is running on ESP32. Let me quickly run this script to see whether this script is working fine or not. So yes, now you can see this message at the shell or REPL of this MicroPython. I am making it a little bigger. So here, successfully connected with Wi-Fi, and the IP address is also being allocated to this ESP32, right? So this is the IP address of the server, but yes, that ESP32 is also having one IP address. So let me quickly close this program by pressing Control C, and let's see what about the server. For server, sorry. So this is the server side script, and this script I have written on Raspberry Pi here on the console. If I'm making it, I'm zooming it a little bit. So here you can see that I am working with the Raspberry Pi. I am basically accessing this Raspberry Pi using the SSH protocol. That is very popular protocol for headless connection of Raspberry Pi by using your computer. So this is the server side script, and in this script we are using the threading module as well, so that our server may be capable of handling multiple clients at one time. I'll tell you that how this threading module is working. So this is the server IP, and easily we can get the IP address of Raspberry Pi. I'll show you how we can do it. Then the server port buffer size. Buffer size means how much data we are expected to receive at one go. That is 1024 bytes. Roughly, it is equivalent to 1 kilobyte of data we can receive at one go. Then the formatting scheme, that in which scheme we are going to format the data, we have discussed with ESP32. The same scheme we have to use here at the server end. Then the encoding and decoding process can match with each other. And backlog means how many connection requests we can use as a backlog. like if one connection is in the process, then second connection can be can wait for some time. So the script starts from here. This is the very first thing that is going to be run on the script. The try and accept modules are here. The first thing, in the server we have created the socket by using socket.socket, and then we are setting some options for the socket so that we can use the same port when we are restarting our device. Otherwise, if you are skipping these lines, then there is a chance you may get an error message if you are continuously running and closing your programs on the server. So to avoid that error message, I am using this set sockets opt method here, API here. Then we are binding that socket with the server credential like server IP and server port. This is exactly similar that what we have done with the ESP32. Then server socket dot listen, that means how many devices can be used in the backlog. And finally, we are printing that server is up and running. Then we are basically accepting the client request here in this while true loop, that is an indefinite loop. And whenever we accept any client request, we are getting two things, two parameters. One parameter is the client socket and the address of that client socket, that is basically having IP address of the client and the port of the client. After that, I'm using the threading module to create a thread. Thread is instance of a function which will run for that particular client connection, whatever the client we are going to mention with that thread. So threading.thread, the target is the callback function is the client handler. We will define that callback function, and the arguments that we will pass into the target, that is the client handler. These are the two arguments, like client socket and the client address, so that this function, this callback function, will always work for this client socket and client address. Then finally, we need to start the thread so that after starting the thread, our program is basically coming at this point again. Now our server is ready to accept the connection from the new client, while the previous client is being handled by this callback function instance, that is a client handler. This is known as the multi-threading in the TCP servers that we are doing. And other things are basically the exception handling and the closing clean exit from the server. Let me quickly show you the client handler function here. This is the client handler function that we are using as a callback function. And here we are receiving the data from the client. Remember that data will be available into the byte format because we are receiving that data from the network. And then uh, we are decoding that data. If there is no data, that means the client is not sending any data, we can declare that client is disconnected from the server. But if we are getting any data, then we can basically decode that data and strip that data. Then we need to basically pass that data so that we can get our required parameters. So these are the parameters that we require: device ID, timestamp, temperature, and humidity. And what we are doing, message dot split, because we have created a string with comma, that is a common separate comma separated file. So for that purpose, we are splitting that string with the help of comma, and we are basically modifying the things so that we can get the clear values. So this is the server side script, and let me quickly tell you that how to run that script on your system. So here, this is the Raspberry Pi console or terminal which I have opened on my system. Let me clear the screen first. Okay. So here, if you can see that the username is Pi and the host name is Raspberry Pi. So if I'm running the ls command, we can see the server.py command, server.py file is available on this Raspberry Pi. Quickly run this python server.py, and now we can see that server is up and running at this particular IP address. So let me again put it here and open the Thorny so that I can run the client. So okay, so on the Thorny, that's we are going to run that script again. So here you can see that in the Thoni, our ESP32 is trying to connect with Wi-Fi and successfully connected. And here you can see the data. Whatever the data we are sending from ESP32, we are sending data like ESP32 sensor 002, and here data received, client IP and port and time, temperature and humidity. We are not printing here device ID, and we can print that as well. One more thing you can notice here, the time, there is a difference and that time may not be correct. Where is the time? Yeah, here is the time. This time is basically coming from the epoch, and why this time is not correct, let me tell you the reason and how you can fix this thing. Because in the ESP32, we are using the time at the server, whatever the time is being sent by the ESP32. And in the ESP32, we are not getting the real time. So if you are interested to get the current date and current time, you can use NTP server in your ESP32 MicroPython script, so that from the NTP servers you can get the current date and current time. So guys, this is how we can basically send data from sensors to server. Here on my screen on the left hand side, you can see that this is ESP32 program is representing the sensor, and this Raspberry Pi is representing the server. So we are successfully transferring data from sensor to the server, and I have explained you that how that data is being transferred using the TCP IP communication protocol. So let me stop this client first, and let me stop this server. Okay, now both things have been stopped, and let me quickly sum up this session. So the common industry problems with the TCP communication protocol, it is, I'm not saying that TCP is the 100% fail-safe protocol and every time it will work as a desired protocol, but most of the time it solves a purpose and it is a fundamental protocol. If you are interested in IoT, you must start with the TCP communication protocol before going to some more advanced protocols like HTTP or MQTT. The TCP is the foundation and the fundamental protocol. HTTP and MQTT both are running on the TCP IP. So network drops is a problem. Server may not be listening. It may be a common industry problem. Port blocking is the very big problem, and to avoid this problem, we are using that set socket opt. Then improper socket closing is a problem that may harm that port, and memory leaks on devices. Generally, these memory leaks happens with the microcontrollers, and microcontrollers are the devices which are directly connected with the sensors. So the microcontrollers or the sensors data is basically being communicated with the help of microcontroller. So memory leak happens there at the microcontroller end. Then where the TCP sockets fit raw TCP, MQTT, and HTTP. If we are talking about the raw TCP socket, it is giving us the full control on the application and more responsibility. It is also coming with the TCP sockets. But if we are choosing the MQTT protocol for our application, it is a lightweight and scalable protocol. Since because of this feature, a lot of applications are basically using MQTT nowadays in IoT paradigm. And HTTP is simple protocol. Most of the time, web servers are basically communicating while using HTTP or HTTPS. Additional S is for the security purpose only, and this is nothing to do with the general functioning or fundamental functioning of the HTTP protocol. But yes, HTTP comes with a lot of headers, so that these headers are making this bulky protocol, and it can consume more bandwidth or more time may be consumed in transferring data from one device to another device. So it is a quick tip for you guys if you are learning the IoT, or if you are basically starting with the IoT, then understand the TCP protocol first, then frameworks make sense. The other framework makes sense. Then the key takeaway from this session is IoT communication is not a magic. It is a very, very strategically designed work. And always industries are looking for people who understand that how data is being communicated from one end to another end. Then TCP sockets are the foundation for any IoT application engineers. Then libraries abstract but not replace the fundamentals. Please remember this thing. If you are clear with the fundamentals, you can use libraries, but all the time libraries may not be useful for your application. And the understanding of these TCP or these fundamental protocols improves debugging and the system designing approach. So guys, these are the few quick key takeaways from this session. I hope you have liked this session. And again, I'm requesting, if you are working with IoT systems, you need any help, or you need further discussion for any of the topic of IoT, you can easily connect with me. Here, my email ID is given, providing at the screen. One more thing to all of you, like one feedback form link is being in the chat box. So please fill that feedback form so that we can send you the e-certificate for attending this webinar. Any questions? I'm waiting. If you are having any questions, you can ask. From the audience, if you're having any questions, you can ask those questions. You can unmute to yourself, or you can raise hand. We will help you, or you can write your question into the chat box. Okay, I believe that there is no more questions. So again, I request you to fill that feedback form, and so that we can send you the e-certificate for attending this webinar. I hope that all of you have liked that webinar, and very soon we'll be meeting again with a new topic related to that. You can suggest your topics as well to us. You know, are having my email ID. You can write to me at any point of time and tell me that on which topic you want to deliver me a webinar or the online session, like that.
Kindly fill the Google form so with the name which you wish to have on your certificate.